Okay. We're going to draw a triangle. And I want you to draw a triangle that obviously has three unequal sides. To me, I think it's pretty obvious that those three sides are unequal. Would you guys agree with me there? I'm going to say this, and this is just kind of in layman's terms, but the length of the sides of a triangle are determined by the measure of the angle holding said side. Holding the side. And vice versa. Bigger the angle, bigger the side it's holding. Bigger the side, bigger the angle holding that side. Once you get caught up there, we'll talk about what we're talking about here. This is what this whole section is based on. Just take the whole thing, put it on your desk, in case you need it. All right. Everybody stop writing, look up here. Now, what do I mean? Okay, here's what I mean by this. The best way I can describe an angle holding it is to think of Stickman, and what does BC and AC look like? His what? His arms. And as the Stickman opens his arms up wider, which makes the angle what? Bigger, what happens to the side he's holding? It gets longer, doesn't it? As he closes his hands together, the side gets what? Smaller. So that's what I mean, that the length of the side he's holding, in other words, the angle opposite it, is directly determined by the size of the angle, or vice versa. So, with that in mind, I want the sides from, and don't write this down, from biggest to smallest in this figure here. So here's what you got to think of. We've already kind of drawn this guy, right? Well, I could draw it, turn it like this to try to make it look more realistic. It is a stick figure, though. And then there's this guy and what he's holding, right? And then you turn it like this, and then there's this dude and what he's holding, right? As corny as that is, it does give you a sense of what I'm talking about, doesn't it?
Yes.
Who's holding the most? Because he has what? His arms are open the farthest, aren't they?
Yes.
So what is the biggest side? A to what? Why would you say A to B? Is he holding that side? What's he holding? He's holding this side right here. And doesn't it look like that's the longest? But you can't always go by look, can you? I made the angles pretty far apart here so it'd be kind of obvious. So the bigger this angle, the longer the side it's holding. The angle's holding. So our biggest side is side what? Again, it's not AB. A to C, because that's what this guy who's open 95 degrees, whose arms are open 95 degrees. What's the next biggest side? Why? His arms are open what? And that's the next biggest angle. What's the smallest side? Because he's only at what? 25 degrees, right? So all you got to do, in essence, the stick figures are here to explain to you why and help you maybe remember it a little better if you forget. But at the same time, all you got to do is find the biggest angle, go opposite it, and that's the what? Biggest what? Side. Would you agree? Find the next biggest angle, it's the next, and go opposite it, it's the what? Next biggest side. Now, with all of that in mind, let's say I didn't know anything about these angles. I don't know anything about those angles. But I know that this side is 10, this side is 8, and this side is 15. Now, could we list the angles from smallest to biggest? Could we do that? First of all, what do you have to look at? First of all, what am I asking for? No, I'm not asking for that at all. I'm asking for what? The angles from what? Smallest to biggest. So I need to find the smallest one. So what do you think I'm going to do here? Find the smallest what? Side. What's the smallest side? Did you say 18? The one that's 8. How do I determine which angle is affected by the length of that side? The one that's holding it, it would be what? So the smallest one is angle what? Well, if I want the next biggest, I go up to the next biggest side, which would be? No. I'll ask for side. The AB, the one that's 10. So then I look opposite it, the one holding that side, that's the next biggest angle, angle C. And then the largest angle would be the one holding the largest side, which would be angle what? How easy is that? Pretty easy, isn't it? Okay, that's in essence what this section is based on. If you look on page 292, do you think this is basically self-explanatory from what they just told us? In any right triangle, The largest side is the hypotenuse. Why do you think that is? It's opposite the biggest what? Angle. Okay? This is a 90-degree angle, right? Is there any chance either of these angles are bigger than 90? No, because there's only 90 degrees left for both of them. If we're thinking whole numbers, the most it could be is this one 1 degree and this one 89, right? But the angle opposite the 90-degree angle would still have to be what? The biggest side. So the hypotenuse in a right triangle is always the biggest side, is it not? You should also realize that because of what? C squared equals what? A squared plus B squared. Obviously, C is going to be the bigger side, isn't it? Okay, that's basically all that theorem says. Let's get our worksheet out. List the angles in order from least to greatest. This is another thing they'll do on this. Okay? Sometimes they'll ask for least to greatest, sometimes they'll ask for what? Greatest to least or biggest to smallest. Jacob, can you hand that back, please? Okay. So they want the angles from what? Smallest to largest. How am I going to find the smallest angle? Find the smallest side. What is the smallest side? J to L. What angle is holding this side? So it's angle K. Then what? What is the next one just a little bit bigger but not the biggest? Would be what? What is the angle holding this side? And then obviously, what's the last one? Not too terrible, is it? But if you were looking at this, because they're all so close and the way they've drawn it, it'd be kind of tough to tell, wouldn't it? So we can tell by the lengths. It's obvious on probably ones like this, but let me give you fair warning. They don't have to draw it to scale, do they? So you'd better what? Look at the sides. They want the smallest. So to find the smallest angle, we find the smallest, which is? What angle's holding it or opposite it? So angle P. Then what's the next biggest side? What angle's holding it? And when they get kind of cockeyed like this, it's kind of not as obvious which one's opposite either, is it? You got to really pay attention which one's holding it. So that would be angle R. And then obviously, what's the next one? There's only one left. Think we can do that? Okay. Here they want us to go name the sides from what? Least to greatest. To find the smallest side, I need to find the smallest what? Now, when you do these problems, of course, draw the figure, label the figure. When you write the answer, write it correctly. What is the side holding the smallest angle? That's the smallest angle. What side is it holding? So what's the smallest side? Do I write it like this? No. That means the length from E to F. That means segment EF. Okay, what's the next biggest side? I find the next biggest. What side is it holding? So, next one's a 71-degree angle. It's holding what? Not so bad, is it? Can we do that? Number 7, identify the angle with the greatest measure. I want the greatest measure. I got to find the greatest what? Side with the greatest length. That's 6.8 miles, isn't it? What angle's holding it? Find the side with the greatest, identify the side with the greatest measure. How are they trying to trick me here? They didn't draw all three. What had you better probably do? Add these two together, see how much is left. How much is left? 79 and 49. What is that together? 118? Or 128? 138?
128.
Well, no, 118.
It's 128.
Okay.
Yeah, it's 148.
So how much is left? 52. Those three add to 180. So what's the side with the greatest measure? To find it, I find the what? To find the biggest side, I find the biggest.
Angle.
What is the biggest angle?
It's G.
79. What side is it holding?
H.
You guys think you can do that?